Okay, so what we're about to do is we're really going to deal with discrete random variables. This is only works with discrete because continuous random variables, remember, they don't equal a specific probability. Like you can never say, this is a continuous random variable, what's the probability that x equals 1? You would know that, we learned that yesterday, that if that was a continuous random variable, the probability would be 0. So in the Flamingo book, they actually do some of this part in 6.1. I combine it all. So again, this is section 7.2 in the blue book, 6.2 in the Flamingo book. Now the first one that we're going to do is we're going to deal with means. I am going to tell you that the first thing that we do, it should not be a surprise to you, considering how many times you guys have figured out what you need on your exam in order to get an A. That is what you guys do. Now, I'm not going to lie, my other kids are figuring out their exam score so they can get a D. So, I do not kid you. I have had kids, Miss Fleury, what do I need to get a D? Okay, well, let's figure this out for you, okay? So, you guys are figuring out what you need to get an A. So, what we're going to find is the mean. So the mean of a discrete random variable x is its weighted average. Each value of x is multiplied by its probability, or weighted by its probability. You guys, you know what I'm talking about because semester 1 is weighted, or probability for semester 1 is 0.4. The probability of, not semester 1, I'm sorry, quarter 1 is 0.4, quarter 2 is 0.4, and the exam is 0.2, right? Now, that's your mean. Even though we're talking about probability, that's your mean. So to find the mean of your semester grade, that's what we do. 0.4, 0.4, 0.2. Okay, so to find the mean of x, we have this example down here, and I'll show it to you. Multiply each value of x by its probability, then add it all up. And of course we're going to do an example because we just need to. And I think it's important. Okay, so the mean of a random variable x is called the expected value. And I want to show you this. So if you see expected value, you see mean, and you know there's probabilities, it means, hey, we need to multiply it by some probabilities. Okay? Anybody want to share their grades with me? Like what you got quarter 1? Go ahead. So we got a 90, so quarter 1 we got a 97. What do you have now? Okay. And of course you want to know. Yeah, for an A. Okay, so, oops. So what should our exam grade be? So, how do we do that? We know we do 0.97. No, not 0.97. Ignore that. That's an accident. Look, that's just a parenthesis. Times 0.4, right? Plus 92 times 0.4 plus 0.2x should equal what? 90. That is a horrible math teacher right there. Let me tell you, don't do that. I hate when kids do that. Yeah, I do. I hate it when they do it. I know that's a strong word, but I do. And what's that saying? Do as I say, not as I do. Yeah, please don't do that. Okay, so 97 times 0.4, right? Plus 92 times 0.4, 75.6 plus 0.2x equals 90. 90 being our expected. 90 minus 75.6 divided by 0.2. Woo, look at that. So, you get a 72 on your exam and still get a 90 in the class. Okay? You guys, that's the expected value. It's just it's just weighted, right? So, again, you guys, just make sure that remember that expected value and mean are the same thing. And a lot of kids will say, well, how do you know? Like, I'll read a question and they're like, well, how did you know that was expected mean? As soon as I see some type of probability in there, like, oh, you can get an A 40% of the time, I know, oh, if they ask me about mean, it's going to be expected value. Okay? Now, let's move on. Law of large numbers. I need you to know that this does not mean 1 is the loneliest number. The reason I say that to you is because one time on a quiz, I asked what the rule for the law of large numbers is, and a kid told me 1 is not the loneliest number. I do believe I gave him a point for making me laugh. Lucas. Everyone knows. It's going to be Lucas, right? So, as the number of observations increases, the mean of the observed values of x approaches the mean of the population, mu. So, the more observations we do, the more samples we take, the closer and closer we actually get to that population mu. Okay? You take one mean, not as close. You take 1,000 means, we're going to get closer to the population mean. You guys, for right now, this probably is not as important as it will be when we get to, they introduce it here now. It will, when we get into chapters, when we start talking about sampling distributions and we do our inferences, it will come more into light. Okay. The more variation in the outcomes, the more trials are needed to ensure that X bar is close to mu. So you guys, these two things are really setting you up for the sampling distributions that we will do second semester. Okay. If X is a random variable and A and B are fixed numbers, then the mu of A plus BX equals A plus B mu X. Basically what that is saying is, and we did this. This is a linear transformation. Remember when we did that? We did those in chapter 1, maybe chapter 2, where we know the mean, and then we were like, oh man, we were supposed to. It was in inches, but we were supposed to measure it in meters or in centimeters, and we just plugged the mean into the equation. That's what that's saying. If you know the mu, you can plug it into this equation and get the new mu. That's basically what that's saying. If X is a random variable. Now, if X and Y are random variables, again, notice the word random. It has to be random. So these are, it's things that now are getting a little bit more specific. Is it random when you read the question? You can add the two means together and get the new mean. I'm going to show you what I mean by that. I'm going to show you actually two questions. Okay. So here's this example. So all the 10th graders took the PSAT. Did you take the PSAT? Okay. so all the 10th graders took the PSAT. And they get a score, right? So suppose this equation, y equals 20 plus 10x, converts a PSAT math score, x, into an SAT math score, y. Suppose the average PSAT math score is 48. What is the average SAT math score? Now, I know, it says random. This is kind of a random variable. So we know that the mu of the PSAT is 48. Okay? And our question is, right, well, if I get a 48 on the PSAT, what is that equivalent to in the SAT? I want to convert it, right? Because I want to know what it means. So to find the mu of the SAT, this is going to be my x. The 20 is going to stay. I'm going to multiply it. You guys, these numbers are not, this is just hypothetical. Does everyone understand that? Please do not try to do this at home. Okay. So if you got a 48 on your PSAT, you would get, it would be equivalent to a 500 on the SAT. Yeah. So again, do not play this at home, okay? Do not use this equation at home, as it is just an example. But do you guys see, I took the mean, I plugged it into the equation, and I got 500. And you guys, we did this with, I think we did the equation where Mary was measuring pythons, and her partner measured in inches, and she's like, that's not what I wanted them in centimeters, and we converted it to centimeters. It's the same thing, okay? Okay, here we go. So you got a 625 on the math. You got a 590 on the verbal. I want to know the combined. You guys, how many of you have done this before? The math plus the verbal equals 625 plus 590. So your combined score is 1,215. If in your head you're thinking, that's really low, just keep it to yourself. Okay? Just letting you know. Okay. Ready for the next one? We're doing good. Okay. If x is discrete, here we go. The variance of a discrete random variable. So if x is a discrete random variable with a mean of mu, then the variance of x is okay, so sigma squared, that's standard deviation. X is the variable. What are you like x is just what you're looking for. It's going to be in context of the problem, okay? So to find the variance, it's going to be the observation 1 minus the mu squared times the probability of the first observation. So observation 1 is going to have a probability. Observation 2 is going to have a probability. It may be the same as the first one. It may be different, but you're going to multiply it by that probability. You're going to keep going on until you get to the final observation minus the mu squared times that probability. So to find the variance, you guys, it is this long one. And I am not going to lie to you. There is no way to do that variance. There is, I mean, unless you make a table, but there isn't, do you guys understand? Like there's not a key that you can hit. Where there's a key, you can find everything else. Do you have to do those by hand very often? Probably not, but you know that you're going to have to do at least one for me. Okay, the standard deviation Sigma x is the square root of variance. You guys, I cannot tell you how many times kids have forgotten this. And this is really important where they are going to give you variance. They're going to give you the variance and they're going to specifically ask you about the standard deviation. They are going to do that. Variance is going to be all over the place and your answer is going to have to be in standard deviation. And this is what's going to happen. They're going to give you the variance answer. Then they're going to give you the standard deviation answer. Every time. They're going to give you those two answers because they're going to distract you from the real answer. Yes, AP loves that. Okay. Now, rules of variances. So, very important. With variances, you can add, you can do all of that. Standard deviations, you can't. You can't add two standard deviations. You can add two variances, but you can't add standard deviation. So, if x is a random variable and a and b are fixed numbers, doesn't that sound a lot like we just did on the front, right? You could plug the mean in. To find the variance of the new one, you're going to take the b, and what do we use b as usually? What does b mean? In our case, in stats case, it's usually the slope. We mix it up. Yes, in algebra you are actually right, but in stats, b is our slope, right? And then we multiply it by the variance. This formula is not on the formula sheet. They give you a lot of other formulas, but this one, not on the formula sheet. I know. Now, if x and y are independent, random variables, then I want you to pay very close attention to what I'm about to write. And please understand that you're going to want to tell me that I wrote it incorrectly, and I have not. Okay? I promise you. If it says, find the sum, right? It says these two variables are independent, please find the sum. Then you can add the two variances. Now remember, you can only add variances. You cannot add standard deviations. What it's going to ask you is, what is the sum of standard deviation? You have to put it in variance, then you have to put it in the variance form. You have to do this, and then take the square root, okay? You add variances, then you take the square root. Very important. If it says, find the differences of the standard deviations or the variances, so this time, we're going to find the difference. Pay close attention to what I'm about to do. To find the difference, you add variances. You never subtract them. You always add them. Even if the question is asking difference or sum, you add variances. If there's anything else that you took away from today, this is probably the most important. It is one of the ones that they will have, and I know I will have on next week's test, and it will be on the exam. It does not matter if it asks you to find the sum of standard deviation or the difference of standard deviations. You always add the variances. Okay, that's today's lesson.